All right, let's talk about the transpose of a matrix. This is a vital concept in matrices that you really need to have the right understanding of. So if you look at, we're having two matrices in front of us, and the concept of transposing a matrix is that you would be interchanging the rows. So rows will become columns, and columns will become rows. That's the concept of matrix transposing. So what you have to do when you are told to transpose a matrix is to change the rows to the column section, and the column section will automatically move to the row section. Now, it is important for you to be able to identify the rows and column of a matrix before you can effectively transpose the matrix. Now, the rows of a matrix is the horizontal sides of the matrix. So right here, this is the horizontal side. So this will be row 1 of this matrix A, while this will be row 2 of this matrix B, matrix A rather. And then if you look at the vertical side, what we have right here, this will be column 1, this will be column 2, this will be column 3. So we have column 1, column 2, and column 3. So in this matrix now, we've been able to identify the rows and the column. So the concept of transposing a matrix is that you would have to interchange the rows with the column. So what we have to do right here is to bring in, by the way, you often write a matrix transpose like this. That means we have A raised to power T. So when you see anywhere where A raised to power T is written, that's just synonymous for saying transpose matrix A. So this is the transpose of matrix A we want to do right here. So if you look at this, we want to interchange the entire row 1 to become column 1. So wherever we saw every element of row 1, we're going to bring it to become column 1. So we have 2, 4, 3, which is the element in row 1. It has become that of column 1. The next thing to do is to do that of row 2 and make it become the column 2. So row 2 becomes column 2. We have -1, 3, and 0. Now this will be whole because you can see we have successfully changed row 1 to become column 1. Row 2 is now column 2. And if you can investigate further, you would see that column 1, which is 2 and -1 before, is now row 1, 2 and -1. Column 2, 4, 3 is now row 2, 4, 3. And column 3, which was before 3, which was 3, 0 was before in column 3, is now in row 3. So this way we have successfully transposed this matrix. So one of the things that happen when you transpose a matrix is sometimes the order will have to change. So this order we had before, we had this matrix A having an order of 3, 2 by 3. So before we had a 2 by 3 matrix. But when we transpose it, now we have a 3 by 2 matrix. So this is the effect of transposing a matrix. Now look at matrix B. Matrix B, we have an order of 2, a 2 by 2 matrix. Following the same procedure, of course, we can recognize the row, this as row 1 and this as row 2. And this is column 1 and this is column 2. So what we have to do in order for us to transpose matrix B is that we would have to, B transpose will be changing the rows. Row 1 will become column 1. So we have changed row 1 to become column 1, and we will change row 2 to become column 2. This is our new matrix, the B transpose. Now, in this case, you can see that the matrix maintained the same order. So B transpose is still a 2 by 2 matrix. So this is the concept of matrix transposing. You interchange the rows with a column. All right. I want you to attempt these questions. I want you to transpose the 4 different matrices we have right here. We have matrix A, we have matrix B, we have matrix C, and matrix D. And I want you to write in the comment section the order of the transpose that you were able to get. So when you're done transposing matrix A, what was the order of the transpose of matrix A? What is the order of the matrix B when you transpose it, and what is that of C when you transpose it, and what is the order of matrix D? All right, I really hope this video was clear to you. If you have any question, please drop in the comment section. I hope to see you in the next video. Bye-bye.